Okay, lesson 2, part 2 of the circulatory system has to do with the parts of the heart. And so this is the exterior view and some of the parts that we're going to be talking about. First of all, remember when the long bones, God put a protective covering around them? And it was called what? Periosteum. Peri, around. Like perimeter. And so God also put a sac, remember, around the lungs. They're called the pleural membranes. And there's a sac around our heart as well. All these sacs are for protection, especially the pericardium. Peri around, cardium always has to do with cardiac, the type of muscle tissue that makes up the heart. And imagine your heart beating on an average of 72 times a minute, and the rib cage and the lungs and everything else that's by the heart, how much friction there would be. So the pericardium, there's some special cells that secrete a liquid, and the pericardium is what's holding that liquid. So it's a slippery sac around the heart, and that then is going to reduce the friction that is made by the pumping of the heart. So a thin sac completely enclosing the heart protects the heart from rubbing against the lungs and the walls of the chest. The septum is a muscular wall that's in the middle of the heart that divides the heart in two sides, a right side and a left side. So it's dividing the heart lengthwise. We have 4 chambers in our heart. There are some organisms that only have 2 chambers, and that's a lot of aquatic organisms like fish. Fish only have a 2-chambered heart. Then we have some organisms that have a 3-chambered heart. A good example are reptiles. They have a 3-chambered heart. So we're going to be studying and looking at the frog when we do a dissection of the frog, where it has 3 chambers. The most efficient type of heart is the one that has 4 chambers. And so we have a 4-chambered heart. The 2 upper chambers and 2 lower chambers. And another thing that they refer to them as cavities, because cavity is a hole. It's empty. There's space in there, just like a cavity in your tooth is a hole in your tooth. So these are 4 chambers, or 4 cavities. Let's talk about the upper 2 first. They are called atrium singular or atria plural. Real old books, you'll see them called auricles, but now they're referred to as atria or atrium. They're the upper chambers. Their purpose in life, and you need to know this, is to collect blood. Now I want you to notice, look at that drawing there, and look at the R and the L and what side they're on. When you look at a diagram of a heart, the right side of the heart is going to be on the left side of the paper, and the left side of the paper is going to be the right side of the heart. So the left side of the heart is on the right side of the paper. That's because if you took it out of your body and then put it on a piece of paper, the right would be on the left and the left would be on the right. So you've got to remember that whenever you're doing a drawing of the heart. So we have a right atrium and we have a left atrium. They're collecting blood, and the key is what type of blood are they collecting. So the main organ of our circulatory system is the heart, and it is that muscle that is pushing blood through the entire circulatory system. So this heart has a big job to do. The heart is a muscle. It pushes blood. Blood enters the upper 2 chambers called atria plural, atrium singular, and then they're going to go from an atrium into a ventricle, because blood's going to leave through the lower 2 chambers of the heart called ventricles, because the ventricles are the pumps. So the right atrium, it is getting blood from our body. So all that blood that has been giving up oxygen, taking on carbon dioxide. So it's deoxygenated blood. Or remember the term that your book uses, and the new term for it now is oxygen poor blood, because it just has little oxygen and a lot more carbon dioxide. Well, that's the kind of blood that the right atrium is collecting, because it's coming from the body. The left atrium, though, the blood is coming from the lungs. So in the lungs, it has gotten its rich supply of oxygen and gotten rid of most of the carbon dioxide. So it's oxygenated blood or oxygen-rich blood. That's what the left atrium is collecting. So we got two collection chambers. They're the upper ones. They're the atria. The right is the deoxygenated, oxygen-poor blood. The left is from the lungs, so it's oxygenated or oxygen-rich. The lower chambers are the pumps. So they're the ones that have the job of pumping. Now that's not really a good picture there because if you see, the septum has a hole in it, so that's really a disorder because that little black arrow that goes from the right ventricle to the left ventricle should not be. It's a solid wall unless you have a heart defect there. So the pumps, well, the key is we've got two pumps because they're pumping to different places. So now think about the blood that's in the right atrium. It's deoxygenated. So it is going into the right ventricle. So it's oxygen-poor blood. So do you think that blood is going to be pumped to the entire body? No. It's got to get oxygenated. So the job of the right ventricle is to take that poor oxygenated blood and get it to the lungs so it can give up the carbon dioxide and take on oxygen and become oxygen rich. And that's the job. So it's not as big of a pump. It's not going to be as muscular because the lungs are fairly close. It's not going to have to pump very far. But the one that has the big job is that left ventricle, because it's getting that oxygen-rich blood, that oxygenated blood from the left atrium that's just come back from the lungs, and it goes into this left ventricle, and now it has to be pumped to the entire body. So when you look at, we are going to get a chance to look inside some hearts. I want you to observe these two ventricles and look at the muscular wall. The muscular wall on the left ventricle is going to be almost or around 3 times thicker than that on the right ventricle, and that's because of where it's pumping. Here's an illustration from your book showing our circulatory system with the arteries, the heart, and the vein, and there you can see the 4 chambers: the right atrium, the right ventricle, the left atrium, the left ventricle. Notice the coloring that they're using. Blue will always illustrate deoxygenated or oxygen-poor blood. Red will always illustrate oxygenated blood or oxygen-rich blood. Here's, again, from your book. I want you to look at this diagram. Number 1, the blood vessels bring oxygen-poor blood from the body to the right atrium. Other blood vessels bring oxygen-rich blood from the lungs into the left atrium. Contractions of the atria then are going to push the blood into the ventricles. The septum keeps the oxygen-rich blood on the left side of the heart from mixing with the oxygen-poor blood that's on the right side of the heart. Contractions of the left ventricle are going to push that oxygen-rich blood to the body, and contractions of the right ventricle are going to push that oxygen-poor blood to the lungs. Just what we've been talking about. And here's externally where you can see the right atrium, left atrium, the right ventricle, and the left ventricle. Now, what always controls the flow of blood in our circulatory system is valves. Remember, arteries don't have valves because of the pressure, but veins do. Well, our heart has 4 kinds of valves, 4 valves. The top 2 we're going to talk about, they're grouped together, and the bottom 2 are grouped together. So there are 4 valves in our heart controlling the flow of blood through our heart. The top 2, which are illustrated there with the T and the M because that's their names, they are commonly referred to collectively as AV valves. Now look at what the AV stands for because you need to know that. Arterioventricular valves. Now look where they're placed. What's above that T? What's above that M? An atrium. Arterio, atrium. What is below the T and below the M? A ventricle, ventricular. So that's why they're called that, because these valves, the AV valves, are between an atrium and a ventricle. Now the first one is called the tricuspid valve. It's the valve, and this is underneath it, because it's flaps of tissue. Those are the little muscles that control those flaps. It's between the right atrium and the right ventricle. So what is it controlling blood? Deoxygenated blood coming from the right atrium going into the right ventricle. That's the job of the tricuspid valve. The other used to be called the bicuspid valve. Actually, the tricuspid is called tri because of 3 flaps of tissue, and the bicuspid is two flaps of tissue. But now it is referred to as the mitral valve. The mitral valve is, again, between an atrium and a ventricle, so it's between the left atrium and the left ventricle. So it is controlling oxygenated blood that just came back from the lungs, going from the left atrium into the left ventricle. Then the other 2 valves they're referred to collectively as semilunar valves. Has to do with their shape and the heart and the moon. Lunar means moon. It has to do with the moon. And I forget the exact correlation there. But they're controlling the blood leaving the heart. So they're controlling the blood from a ventricle where it's pumping into an artery. Because remember, arteries carry the blood away from the heart. And you can see P and A. They actually name these semilunar valves after the artery that they're controlling the blood going into. So the pulmonary valve is between the right atrium and, the right ventricle and the pulmonary valve. Whenever you see the word pulmonary, lungs, remember, lungs. So pulmonary is going to the lungs. So a pulmonary, oops, that's wrong. I got to change that slide. Make sure you put pulmonary artery, because it's between the right ventricle and the pulmonary artery, because the artery is carrying the blood away from the heart to the lungs. The aortic valve is going to take blood into the largest artery that we have. So it is going to be between the left ventricle and the biggest artery, which is the aorta, which is carrying blood away from the heart to the whole body. Here's a real picture inside of a heart showing you the tricuspid valve having 3 flaps of tissue. And this one's a little bit better. You can see the muscles there, but they're holding up the 3 flaps.
Your heart is the primary organ of your circulatory system. It is made of cardiac muscle and includes 4 chambers, the atria and the ventricles. During a single heartbeat, both atria contract at the same time. Then both ventricles contract at the same time. A valve separates each atrium from the ventricle below it, so blood flows only from an atrium into a ventricle. A wall prevents blood from flowing between the 2 atria or the 2 ventricles. In pulmonary circulation, blood high in carbon dioxide and low in oxygen returns to the heart from the body. This blood enters the right atrium through the superior and inferior vena cava. The right atrium contracts, forcing blood into the right ventricle. Then the right ventricle contracts, sending the blood through the pulmonary artery to the lungs. In the lungs, carbon dioxide diffuses out of the blood, and oxygen diffuses into the blood. Oxygen-rich blood travels through the pulmonary vein and into the left atrium. The pulmonary veins are the only veins in your body to carry oxygen-rich blood. The left atrium contracts and forces the blood into the left ventricle. The left ventricle contracts, forcing the blood out of the heart and into the aorta. The aorta is the largest artery in the body. It carries blood from your heart to the rest of the body.
Now, our heart is a muscle, and so it's made up of cells, and it too needs nourishment. It needs waste carried away. It needs oxygen. And so God put arteries on and veins on the outside of our heart. They're called coronary. And so their job, the coronary artery's job, is to carry that oxygen-rich blood from, and it's coming right out from the aorta there, and it's nourishing the heart. And if it gets blocked, and that's what a lot of times what causes a heart attack, and if it gets blocked, then that part of the heart that it's feeding is going to die and cause a heart attack. And you need to know the largest veins in the human body are the superior vena cava and the inferior vena cava. And you need to know where they are returning blood from the body to the heart. Remember, the veins carry blood to the heart. And so the superior, it's not called that because it's better. It's called that because it's above. And it is actually returning blood from the upper part of our body. So from our arms and our shoulders, our neck and head area. That blood's going to return to our our heart through the superior vena cava. Then our blood from our lower part, our trunk, which is where your abdomen is, and from your legs and toes and all that, that blood is coming up and it's going to go into the heart through the inferior vena cava. And then, as was mentioned, the largest artery in the human body is the aorta.